All right, so I'm going to assume that we are still on Friday and that you're ready to work example 4. So it says that you have a mass of 0.50 kilograms. So that's this one right here. And it's going at 6 meters per second. And we have a 1 kilogram ball right here. And it's moving this way at -12. And that -12, the negative sign is showing us that it's going to the left. All right, so after the collision, this one moves back to the left at -14. And they want to know, what is going on with this one? What is V2 prime? So M1 V1, M2 V2 equals M1 V1 prime plus M2 V2 prime. So here was my M1, here's my V1, M2, V2, M1 didn't change, V1 prime is now -14, M2 didn't change, still 1 kilogram. But what in the world is V2 prime? So now I just put some numbers in. So a 1/2 kilogram moving at 6 meters per second plus a 1 kilogram moving at -12 meters per second is equal to that 1/2 kilogram moving at -14 plus 1 kilogram moving at some new speed, which we don't know. All right, 1/2 of 6 is 3. So that's 3 kilogram meters per second minus 12 kilogram meters per second is equal to -7 kilogram meters per second plus 1 kilogram times V2 prime. And you have to pay attention to the signs or you'll get it wrong. So 3 minus 12 is a -9. I'm going to bring that -7 over to the left-hand side, so it's going to become a +7. And I still have 1 kilogram moving at V2 prime. -9 +7 is a -2. So if I pay attention to my math, the kilograms will cancel. 1 divided on both sides. So it looks like to me V2 prime is going to be a -2 meters per second. Which means this one right here is continuing to move to the left, but at a much slower rate. Okay? All right, so pause it if you need to. I'm going to move on. All right, so let's see if I can figure out how to get out of here. So I'm going to flip through the PowerPoint. There we go. Same answer we got. Big shockaroonie. All right, let's move on. So we have a freight car moving at 10 meters per second, miles per hour, whatever you want to call it, to the right. This one's not moving. They hook up together, and now twice the mass is only able to move off at 5. So M times V equals M times V. Inelastic collisions are characterized by objects sticking together and permanent deformation. So if you've ever crashed your car, that was an inelastic collision, because I'll guarantee you your car didn't look as pretty after the collision as it did before. Try not to crash your car. It's expensive. Example 5, a 3,000 kilogram truck. So here we have our truck, 3,000 kilograms. Is moving to the right at 5 kilometers an hour. And it's going to hit 1,000, should say kilogram truck, because that still looks like a truck to me rather than a car. And it's moving this way at 10. They're going to stick together. So that makes my equation M1 V1 plus M2 V2 become M1 plus M2, because now they're stuck together, moving at something we can call V prime. So 3,000 kilograms, 5 kilometers an hour, plus 1,000 kilograms times -10 is equal to their mass added together, so that looks like 4,000 kilograms times V prime. So 15,000 here. Minus 10,000 here. Divided by 4,000 kilograms gives me their common velocity V prime. So it looks like to me it's going to be 5,000 divided by 4,000, which is the same thing as 5 over 4, which tells me that V prime is 1.25 kilometers per hour. It's positive, which means the big truck shoves the little red truck to the right. That's all there is to it. All right, now let's see if this lovely PowerPoint agrees with us. So here we go. There's all our data. P before equals P after. Looks just like mine. There we go. We got it right. Good deal. Okay, let's move on. Explosions. When an object separates suddenly, as in an explosion, all the forces are internal, so momentum has to be conserved. There will be an increase in kinetic energy, and the reason for that is you're going to get some kind of chemical reaction that's going to give you some potential energy that now is changed into kinetic energy. Okay, cars are equipped with padded dashboards, and collisions of padded dashboards would be safer than non-padded ones because, all right, so what we're hoping to do with those lovely little padded dashboards is we're hoping that we can decrease the force. So we want to make this force, right? Let me get rid of that. Oh, dadgummit. Just scribbling. Okay, let's clean that up. There we go. What in the world is that? Sheesh, okay. So we're going to decrease the force. We want force to be little bitty, and we want the time to be great big, because we don't want to mess up our pretty faces, so we want the force to be as small as possible. The goal is to reduce m delta v to 0, or that's what happens in a crash, so this is going to go to 0. So if I crash, my momentum goes to 0. Well, I can do it one of two ways. I can make the force be small and the time be great and still reach 0, or I can make the force be huge and the time be little. We talked about that when someone was, I think there was a graphic of a man punching someone in the face. If you want to hurt them, you want this to be big and that to be small. So that's why people pop each other when they're boxing. If, however, you want your face to stay as pretty as possible, we want a great big T and a little bitty F. So we want to increase the impact time and decrease the impact force. And here is your explanation if you want to pause and read that, which would be a great idea, so ask the sub to pause. Okay? All right, let's move on. Recoil. This has been interesting. Guns and cannons recoil. This means that the gun or the cannon moves backward as the projectile goes forward. If you've ever shot a gun, you know what I'm talking about, because as the bullet moves forward, the gun kicks back and gives you a big old nice bruise on your shoulder. And everything that happens in that action-reaction between your gun and the shoulder is entirely due to internal forces. The gases expand, and as the gunpowder explosion, the gases that come out of there expand, and they push the projectile forward, which is the bullet, and the gun or the cannon goes backwards. Again, pause if you need to. So here's my formulas. All right. And check your activity sheet for all of these things, because none of these dates are right since I didn't make any changes. But you have an activity sheet that tells you exactly what to do when, and we will be taking grades on these because it's a short 6 weeks, and we need to get as many grades as possible. All right. I'm going to stop there, and we're going to call that a lesson.